Here we'll do another example of hypothesis testing using the same procedure we used last time. This question says, North Carolina experiences a 42.3% voter turnout in midterm elections. In a random sample of 612 voters, 280 say they participated in the 2018 midterm election. Test the claim that this year's voter turnout is different from the typical 42.3% voter turnout using a 5% significance level. Our claim is that the turnout is different from 42.3%. Now, remember that is different means not equal to. And the fact that we are using percentage tells us that we'll be using little p for population proportion. Remember that if we have less than, greater than, and not equal to, that means our claim is alternate. If we had less than or equal to, greater than or equal to, or equal to, that means that we would have null. Now, since we have not equal to, this means that our claim is alternate and it's going to be not equal to. So we'll say we are going to claim for the alternate hypothesis H1 that little p is not equal to 0.423. Now, for step 2, we write the opposite claim. The opposite must be null because we've already used alternate. And the opposite of not equal is equal. So we'll say for the null, p is equal to 0.423. Let's also think about what type of test we have. If the alternate says less than, that means it's left tail. If the alternate says greater than, that means we have right tail. And if the alternate is not equal to, we have two tail. So this time our test will be two tail. Now let's think about the possible outcomes. If our big P turns out to be less than or equal to alpha, that means our evidence is strong. This will allow us to reject the null hypothesis. Now imagine we crossed out the null hypothesis. That would leave behind our claim. So this means that in rejecting the null hypothesis, we are supporting the claim. However, if our big P is greater than alpha, our evidence is not strong. And if our evidence is not strong, we fail to reject the null hypothesis. Now, if we don't reject the null hypothesis, we stick with the null hypothesis. So imagine we boxed in the null and kept it. That means we couldn't support the claim. And once again, the reason we can't support the claim is because we don't have enough evidence. Now, let's think about, for step 4, how to calculate the test statistic. Now, let's remember the test statistic is going to equal parentheses p hat minus p divided by square root of p multiply q divided n. Now remember, to get p hat, we're going to take the total sample size on the bottom. On the top, we put the people we're interested in. And the people we're interested in are the people who say that they voted. Now P is going to be our claimed proportion. That comes straight from the claim. And Q is 1 minus P. And of course, N is the size of the sample. So, we'll enter some data into Excel. We'll say that X is the number of voters. We'll say that N is the size of the sample. Based on this, we can find P hat. We can find P and Q. So X. The problem says that 280 people say they participated. Those are the people we're interested in, and we'll say that's X. The N will be the size of the sample. We are also told that we have a random sample of 612 voters. We'll say 612 for N. And P hat will be the voters, the 280, divided by the 612. That's the size of the sample, giving us a P hat of about 0.4575. Now the claim that we wrote earlier was 0.423. And so Q will be equal to 1 minus the P we just found. Now that we have everything we need, we can calculate the test statistic Z. We'll say equals parentheses P hat subtract P, divide by square root of P times Q, divide by N. Close the parentheses and press, and we get our test statistic, 1.728. Paint this gold because it is important. That completes step 4. Now, to calculate the big P, we need to find P if it was left tail, P if it was right tail, and P for two tail. So I'll write down the formulas once again. For left tail, we'll say equals norm S dist and say Z, comma, true. To get the right, we do the left and say 1 minus whatever the left was. And then for two tail, we'll take 2 times whichever one is smaller, and so we'll say times min of the left and the right. Let's type this into Excel now. We'll say equals norm S dist, click the Z, comma, true. Then for the right, we take 1 minus the left. For two tail, we'll say equals 2 times min of the left and the right. This is going to be our big P value, 0.083918. Now we compare that against our alpha for step 6. We'll write that big P is 0.0839 and alpha was 0.05. We can see that our big P is greater than alpha, and therefore we'll say that our evidence is not strong. Therefore, we do not reject the null, and we keep the null. We'll box it in here. Now this means since we are sticking with the null, we cannot accept the claim. So for step 7, we'll say we don't have enough evidence to support the claim. Now, remember the claim that we would have supported is that the proportion is different from 0.423. And we want to specify that this is the case at the 0.05 significance level. Now, if the alpha was just a little bit higher, say 0.10, in that case, that would be enough evidence at that significance level to support the claim. But since we have an alpha of 0.05, the evidence is considered not strong enough to pass that significance level.